We have another terrific show and an amazing guest for you today. We are talking on-orbit services and in-space logistics. Welcome to the Tech and Space Leaders Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, John Rood. He is the chairman, CEO, and president of Momentus Space. Welcome to the show, John.
Oh, it's great to be with you, Lisa. Thanks for having me on.
Absolutely. Thanks for making time for this. So, I'm thinking we should just go ahead and start with having you give a little bit of background on yourself and Momentus Space.
Sure. Well, at Momentus Space, we're a young space company based in Silicon Valley, still a small but growing company. We make small satellites, and the same satellite used as an orbital service vehicle that delivers other satellites to custom orbits, or can be, if you will, the delivery vehicle of choice to perform hosted payloads, unique missions. As the market develops, we plan to offer servicing, refueling, things of that nature, inspection, and then on the military side to play a role at supporting our Space Force and our United States efforts in that area, both for the defense, but also for other communications purposes or for the scientific purposes as we do for NASA. And so that's a little bit about the company. We've done four missions to date, three with our Vigoride vehicle shown behind me, and delivered 17 customer satellites and supported 3 hosted payloads. My background is that I came to Momentus a little more than 4 years ago. I had previously worked as an executive at Lockheed Martin and Raytheon, but prior to that, or during that period of time, in some cases coming in and out, I served in the U.S. government for about 20 years, but most recently at the Department of Defense as the Undersecretary of Defense for Policy.
Wow, amazing, amazing background, and really exciting to hear about what Momentus is working on. In fact, you have a space flight, a space launch scheduled for late March, right? Can you tell us a little bit about
That's
that?
right.
And that's going to be Vigoride 7, correct?
That's right. Our latest vehicle, we've shipped to the launch base, and we're preparing her to be integrated along with other payloads that will go on a SpaceX transporter mission. Now, that's targeted for late March right now by SpaceX. And we'll carry 13 payloads on that mission for a range of customers. The anchor customer is the Defense Advanced Research Projects Agency. And there is a payload produced by Caltech that will simulate or actually perform an in-space assembly of a large antenna structure. It's meant to simulate an antenna. And so rods and pieces will be assembled to form a large antenna reflector simulant. So the Vigoride vehicle will end up looking like a big tennis racket in space by the time this assembly is done. And then we have some other payloads that will carry one for the Air Force Research Lab innovation arm called SpaceWorks. And we won a contract to demonstrate low-cost rendezvous and proximity operations. So we will do that. The way we will do it is we'll release a target satellite from NASA. It's called Inspector satellite, and then we'll maneuver to be in close proximity to that satellite. And then later, the Inspector sat will inspect the Vigoride vehicle, as is its mission. And then we're carrying other payloads for NASA on that mission. This is a kind of a truck, if you will, that's carrying many things to space. That's part of the virtue of orbital service vehicles. They can do a multiplicity of functions. And then we have some really cool commercial payloads. For example, one of our partners, Solstar, basically their big technology is to allow you to communicate via standard Wi-Fi with your payload in space. And so we'll carry that payload to space and operate it on orbit, which will be a first for that company. And then we have others, like one with a company called DPhi from Switzerland, in which we'll have a hosted computing environment. Basically, think of it where you can send your code up to space, have it tested, demonstrated, use the sensors on board, and bring the data back down to Earth. All in this case, if you use the Solstar service through your just basic hotel Wi-Fi or wherever you're at in your home or office, and communicate with your payload 24 hours a day. And then we have some other payloads, one that we've produced ourselves, where we have worked with a partner called Velo 3D, a leading 3D printer company. And what we've done there is, with our design, Velo has printed a 3D propellant tank. And so we've tested that on the ground. Now we'll fly it in space and test it in space, because there's a shortage of these things in the space industry, and this will allow us to more rapidly produce them at substantially lower cost than what we see in the marketplace today. And there are really cool payloads that, as I said, we wanted a NASA contract, that are advanced power computing environments, power production and regulation technology that's key to avionics. So just a fun mission that will go on for months, in which we'll demonstrate and test these various payloads or operate them for the customer. And it's just really great to have a whole bunch of these things right at the cutting edge of the leading edge, if you will, of space.
Oh my gosh, that is so amazing. How are you managing so many different missions and payloads all on one flight?
Well, that's the interesting thing about these flights, is that we want it to be economical for our customers. We want a company like Portal Space, which is flying with us for the first time, and they'll demonstrate and test some of their avionics, to have a reliable, agile platform that can be reconfigured. And then by putting several things on at the same time, you bring the cost down. SpaceX has done a nice job of this, for instance, with rideshare launches. We are trying to do that in our own way with our platform, where you can operate in space and stay in orbit for a long period of time. And we want to do this in a reliable, low cost way, to be, if you will, a Chevy truck of space, not a bespoke, highly expensive item, but rather just something that's produced for large volume use. And with the same platform, we can be a satellite. We can perform this role as essentially a space truck, and eventually a kind of space repair vehicle.
Right, right. So, as I understand it, the Vigoride uses a unique, I guess, water as propellant for in-space services. How does this work, and can you talk a little bit about that?
Yes, it's a technology that we have developed, and we're the first to bring to the market. And it's something that we're very proud of, where we have patents. But essentially, the microwave electrothermal thruster, or MET, we use distilled water, the kind you could buy from the grocery store. We don't actually go to the grocery store. We have a supplier deliver it, but it's just distilled water. It's not under pressure. And what we do is we put we vaporize the water. We use a microwave source, a radio frequency, to heat this water vapor to incredibly high temperatures, to essentially about half the surface temperature of the sun. And then it turns into a plasma. That's the easy part, to put a lot of energy into this water vapor and develop a plasma. But the real science then comes into, since it wants to melt through anything in sight, to create a vortex in the exit nozzle, if you will, and a boundary layer that is magnetic, so that this swirling plasma can produce propulsive force. And we've done this. We've demonstrated it on orbit. It's technology readiness level 9. We've done it several hundred times successfully. And basically, we're able to generate a very good ISP, or specific impulse, on par with what we see in leading chemical manufacturers, something on the order of over 280 seconds. And then the thrust is higher than what you would see for an electric or a Hall effect thruster, but less than what you'd see for chemicals. So it's kind of this nice propellant. I liken it in the old days. Diesel fueled trucks and still are commonly used to transport cargo over long distances, because it's efficient. Now, if you've ever driven a diesel car like I have. You go to Europe, you slam your foot on the gas, and it doesn't have this massive acceleration the same way the ones that are operating on regular fuel here in the United States do. But it's more efficient, higher miles per gallon, and so
Mhm.
that's a similar thing that the MET has been developed for, to serve this transportation and multi-purpose uses in a way that's environmentally safe, non-toxic. It's not we ship our satellite, our orbital service vehicle, fueled because the water is not even under pressure. Worst case scenario, you'd have a leak and you'd mop up the floor. So that's part of the benefits of this technology that we've developed.
Wow, amazing, amazing. So I also understand that Momentus has recently had a contract shield program. Can you talk a little bit about that as well?
Yes, our government in the United States, of course, has launched an expanded effort for missile defense. Part of the greater effort on missile defense is the Missile Defense Agency, and they put out a solicitation, and we competed for it. It was called the SHIELD contract, SHIELD IDIQ, Indefinite Delivery, Indefinite Quantity contract. And we're very pleased to have won a position on that. Now, it's a very large ceiling, $151 billion that in this contract vehicle could be made available. President Trump, has used larger numbers on the order of $175 billion to be spent on his missile defense initiative. So it'll be a way for us to be a member of the club here, where we've won a position where future contracts will be competed there. We happen to think we have some unique technologies, or I wouldn't say unique, I'd say rather we can be agile, low cost, in a way that can meet the needs of the Missile Defense Agency and other customers very quickly. So we're looking forward to being a part of that community.
Yeah, yeah. So I guess extending that conversation, given your background in national security, what role do you see commercial space companies like Momentus playing in, I guess, the future?
Yes, and I've worked over the years, in addition to being Undersecretary of Defense for Policy. At an earlier stage of my career, I was a Deputy Assistant Secretary for Forces Policy that included space policy. And I've been in other roles. And one of the things that unfortunately has developed over time is that there's this ecosystem of mostly larger companies that have done business in the defense space, serving the now Department of War, and providing services there, as well as to NASA. But there's been this migration where commercial companies have also developed that have been servicing more commercial customers, in a bit of a divide. There is some overlap between them. And what I see going on right now is that the leaders in the Department of War and NASA really actively trying to reduce that, to say we need to take on more of the commercial innovation, leverage the commercial market more. And it's just part of a greater shift where the government is no longer always driving innovation. That there's a ton of innovation that's just going on purely in the commercial sector, and our government is wanting to leverage that. So I think what you're seeing is an effort to involve more smaller companies, to work out ways to have on ramps, to create pools of companies that can collaborate in certain areas. I'd say the report card so far is a bit mixed. If I were to be candid, over the last 5 years, certainly the mood music and the messaging and the intent from the leadership is strong. I think, but we do have a system, unfortunately, that's developed, and I tried my best when I was in the government. For example, and my office wrote the legislation to create the Space Force and do other things, or the Space Development Agency was one of our initiatives. To In those efforts, got to do things a little differently, and some of that's cultural, but it's also giving people the freedom who are in government to acquire things differently. The acquisition systems become so constrained and, in my view, over-regulated. Um, and so it's a very difficult thing. There have been many studies over the years on acquisition reform, but I'm liking the intent and what I'm seeing so far, whether the current government really trying to change that system to allow for faster cycles of innovation, to bring in technology from the commercial sector. And so I'm optimistic about the future trajectory there.
Yeah, absolutely. Absolutely. That's incredibly encouraging. In terms of in-space logistics, clearly it can be a pretty capital intensive sector. How do you see, I guess, what are the biggest challenges that Momentus faces from an operational perspective? And what milestones do you feel are really critical to getting to that sustainable profitability?
Well, I think the whole area of in-space assembly and manufacture and servicing, refueling, doing things like debris management, is still fairly early in the formation of that market. You are seeing great examples where commercial companies have done refueling missions to demonstrate the technology. You're seeing some proof of principle, if you will, or initial demonstration missions being funded by governments, not just the US government, but some abroad, like in Japan or the UK. So certainly some useful things there, but I think it's going to take a little bit of time, and the government can play a key role here to foster that system. And I think there's two reasons. One, the space industry has historically been fairly conservative, and for good reason. I mean, space is a harsh, unforgiving environment, and it just takes the smallest of things for a failure to occur or an issue or some reduced capability. And so certainly there's a reason that culturally the space industry has wanted to see things demonstrated. However, I think that the imperatives, and both either from a competitive advantage point of view, where you're seeing people show that they can take risks on technology development and not be uber conservative, if you will. And you're also seeing governments feel the need to do things differently because there are much more cost effective ways to perform. Take the mission we're doing now, where we're planning to do in March, where you're doing many things at the same time. That's more economical. That provides a lower value. And doing things like showing you can do in-space assembly and manufacture. I think of it kind of like the IKEA furniture of space. You can buy purpose-built things, but payload shrouds, complexity, the cost of highly articulated things that move and extend and so on in space is hard to do versus taking the components flat packed and assembling them in space. And that I think is the future. And I think what will generate that is the competitive advantage, either from cost, capability, the ability to do things we have not been able to do before. And as that ecosystem develops and builds on itself, I think you're going to see more of that take place. And some of it will be by necessity. I think in the military area, space is becoming a lot like the air domain, where you're having air forces operate with different types of airplanes, fighter planes, bombers, refueling, transportation, airplanes, and similar roles are developing in space. And I think by necessity, that will also require things for multi-purpose vehicles, orbital service vehicles, if you will, that can operate in that environment.
Yeah, absolutely. In terms of the longer term vision for Momentus, how do you see things moving, I guess, beyond transportation and hosted payloads? Where are there other, I guess, essential in orbit service opportunities?
Well, I think that Momentus, with our carrier vehicle, that same technology stack can be used and is used as a satellite. And so I think what you're going to see us, I hope, begin to do more and more of is, in addition to these rideshare missions where we're providing hosted payload services and other things, that we start to use the same vehicle to provide communication services, things like in-space data relay. We live in the information age, and you're going to start seeing, in my view, a lot more operations being done for space, in space, not bringing the data all the way through a little soda straw down to Earth and bouncing it back to space and back and forth across the planet. I think you're going to start to see things where data is collected in space. If you will, the corn is harvested and the husks are removed to just get down to the kernels of corn, the data that is important in space. processed and stored in space and transmitted in space to support other space operations as well as things on Earth like remote sensing. And so I think for Momentus, beginning to play a role in that emerging field for data management, data transport, data relay in space, and then supporting activities on the Earth and doing it in ways where there are smaller satellites with more capability packed is in an agile way. That's what we want to be a part of. And there are always going to be very bespoke, high-end activities, but I think more you're going to start seeing space become, I hope, more commoditized, which will allow for us on Earth to benefit more from it. So, part of our vision is we want to be the UPS of space, if you will, to reliably in a low-cost way deliver you to space, but also support a range of other activities that are resident in space. And so that's kind of where we would like to get to. And we're well on our way. We've won some exciting contracts that point to the future with NASA. After our next mission here in March, we have one planned the following year. And we won 2 NASA contracts to do things like grow semiconductor crystals and return. Some really cool things coming up in our future.
Gotcha. Okay, well, gosh, John, I want to thank you so much for making time to be here today. If someone wanted to learn more about Momentus Space, what should they do?
Just contact us at Momentus. We're at momentusspace.com. We'd love to hear from you and be your ride to space or support your mission in space.
Absolutely. Fantastic. Thank you again for being here. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leaders Show.